Welcome. Thank y'all for coming. Today we're going to talk about the sagebrush conservation design and the state of the sagebrush. And before we get started, I really wanted to say thank you to the folks who've made this possible. So we're going to present part of a special issue that's coming out in Rangeland Ecology and Management. It's all submitted just last week. So that was 20 independent groups working their bums off to get that all done on the time. And I know how much effort y'all have put in over the last couple of weeks, and I really appreciate it. It would not have been possible without it. So this started off with a group of folks getting us together, saying we really need to get a plan for the sagebrush biome. And we started off with this common vision on how we're gonna kind of come together and find those common interests. So it started off with, I guess, 12 organizations. Now we're up to 25, 26, something like that. And it kind of keeps on going. My name is Kevin Doherty, and I work for the Fish and Wildlife Service as an ecologist. The sagebrush biome is one of the least modified landscapes in the world. If you look on the green area right there, that's the sagebrush biome. Places that have less human disturbance than what we're talking about today are places like the boreal forest, Siberia, the Australian outback, the Amazon jungle. So it's one of these wild places where we can actually get out and get away. When we look at the United States, it is the largest continuous open terrain in the United States. And if you look at the human modification values for the biome, our lower 48 on average, we're a full third of just the average. So this is the kind of one of the last best places out there. So what is sagebrush ecological integrity, and what are core sagebrush areas? The simplest way is, if you look at the picture on the left, that is a place that has high sagebrush ecological integrity, and that would be a core sagebrush area. What it is a simple, we take a complex state and transition models, simplify it down into these classes of what we want. And what we want is sagebrush cover, and we want native understories, perennial grasses especially. What we don't want is on the right. We don't want encroaching conifers, we don't want invasive annual grasses, and we don't want human modification. And ultimately what we did is we linked this conceptual model, this vision, to satellites, and we made this index called sagebrush ecological integrity. So now you have a score for everywhere in the biome on a consistent measure that says, how are you doing? Do you have threats or whatnot? Once we have those scores, we can rank them, and the highest places are called core sagebrush areas. They're the ones on the left. When you're looking at those core sagebrush areas, they're going to be dark blue on the next map. That's the picture that I want in your head when you're like, okay, what is a core sagebrush area? So you can kind of go down that sagebrush ecological integrity score, and then you start to get into what we're calling growth opportunity areas. They're going to be light blue in the next maps. Growth opportunity areas are places that have a little bit of threats. A lot of times you might have some invasives, you might have some conifers, or maybe you don't have the grasses aren't as good as you want. That's generally what it works like. Keep on going down, and you start to get to other rangeland areas. In other rangeland areas, about 3/4 of them are going to be the pictures on the right. High levels of threat, conifer encroachment. The other quarter is just not sagebrush habitat. So there's places like the Grand Canyon that are in the sagebrush biome that are in fact not sagebrush habitat. They're phenomenal places, but they're going to be other rangeland areas. So other does not always imply bad. So when you map that across the United States, this is what it looks like. Dark blue areas, picture on the left. And if you go through time, so we link back, start at 2001, we go to 2020, you can see quite a range contraction. Right now, we're going to see some new estimates for losses, and we're looking at about 750,000 acres a year through time. So this is what it was in 2001. This is what it is in 2020. So what caused the losses to the cores? And through time, what we're seeing is the stuff we want, it's about 10% of the losses. So loss of sagebrush, 6%, loss of perennial grass, 4%. Human modification, something that causes a lot of consternation in different stakeholder groups, only 3% of the losses over the last 2 decades. If you go back to the early 1800s and you look forward, there's places that Jeff Bedrosian is going to be talking about where cropland conversion in states like Washington has seen large losses. Invasive annual grass. We all kind of know this. Now we got a number. 69% of the losses over the last 2 decades. Conifer encroachment, 18%. So why is that important? Well, when we're developing this conservation design, we wanted to focus on our common interests. And so we didn't always lead with wildlife, and we validated with wildlife. And the reason for that is we have a lot of common interests. And if you start getting away from stakeholder positions and you think about those common interests, right there, you're looking at 87% common interest between encroaching conifers, invasive annual grasses. Perennial grasses. If there's any society that knows the importance of perennial grasses, this is it. 4% of the losses. So all told, 91% in the same camp. And the reason this is important is it's going to take all of us to come up with the changes that we need to see. So we didn't lead with wildlife, but we validated with wildlife. Greater sage grouse, I'm sure everyone here knows what they are. Petitioned for the Endangered Species Act numerous times through the last couple decades. And the point in this is when we manage for sagebrush ecological integrity, it is ecologically relevant. And we have a theme of chapters in this. And when you look at sage grouse populations, 1996 to 2022, when all these populations are going down, 3% increase. So we got stable populations in those dark blue areas. Those growth opportunity areas, the light blue, 16% declines. Other rangeland areas, 62%. Sagebrush obligate songbirds, same deal. 10 times higher density in those dark blue areas compared to the tan areas. And if you go from a dark blue area to a tan area, you're talking about a 58% population loss. So what does this all mean? And we have a bunch of chapters in here, and they're all pointing towards business as usual is not going to save the sagebrush sea. So a lot of y'all have heard the term defend the core, and I'm just going to take a little bit of time and explain what it is. So if you look at the core, that'd be the stethoscope right there. That's that picture that I showed you on the left with that beautiful sagebrush landscape. That's the core. And if we're going to defend the core, we want to find those landscapes, map them. I just showed you we did that. We work outwards towards the threats. If you start out here, you're in a reactive spot where you're saying, boy, things are really, really bad. We got to do something. And many times when we're in that spot, when we're doing something, we're actually past thresholds where we can actually do something about it. So we asked the question, are we defending the core? And the answer is we are not defending the core. Less than 10% of our conservation treatments for invasive annual grasses were in those stethoscope landscapes. And it was about 23% for conifer encroachment. The consequence of that is we're off by orders of magnitude. The most important thing I think you can take home from today is better spatial targeting and actually defending the core is the number one thing we can do to help close that gap. And that's a decision that's in our control today. Conservation planning is needed to develop realistic business plans. And there's 2 chapters in this special issue on that. And the point is, if you don't understand the status and trends of your threats versus the conservation volume that you can actually do, you do not have a business plan. You have no idea if you're going to be successful. You're doing the best you can with what you got, but what we're finding out here is that's not enough. So when we looked at the Park Service and the National Refuge System, we also found within our sagebrush landscapes in theirs, like can we defend the core, we're off by orders of magnitude if we look at all of our parks and refuges within the biome. However, if you focus on that preventative ecosystem state, we can close the conservation gap. And further, we've identified where those are. In the refuge system and the park system, just 5 different refuges and 5 different parks has over 9% of our resources for both agencies. So we said better spatial targeting can help us. We have 4 different chapters. We have one that we're going to talk about today, expanding conifers, invasive annual grasses, cropland risk, and wildfire. We're not going to talk about wildfire today in the symposium, so I just want to give you one take-home slide to give you an example. If you look at the areas that are colored, those are core and growth areas that are overlaid with a fire risk model developed by Karen Short at the U.S. Forest Service Fire Lab up in Missoula. The areas in blue have lower probability of catching on fire. The areas in yellow are basically these are places that are burning 8-9 times within a 100-year interval. Areas in greens are those kind of going to be a transition state. When you look at it, what we found here is over 80% of our core areas are actually have low fire probabilities based upon our 2022 conditions, and about 70% for wildfire risk. And the point is once you start to actually understand spatially where this risk is and how it relates to other things, and you understand the rates of conservation, you can start to get a game plan. Targeted ecosystem management. Monitoring shows it works. And so there's 2 talks today, one from an NRCS program evaluation, one from a joint conifer cuts between BLM, NRCS, other folks in Oregon, no, not Oregon, Idaho. And the point on this is it's not dollars spent that leads to conservation. It's effective conservation guided by a vision that does it. And what we're going to see here is it's working. So we have done this at scale. We're also going to look, Pete Coates is going to talk about the bi-state sage grouse population. And when you manage for sagebrush ecological integrity, and we're looking at those conservation actions that are geared for those species, the bottom line is the birds got the memo. You can do these actions, you see a population response, it's working. That chapter also highlights that there's things that do not relate to sagebrush ecological integrity that are important to grouse. And you need to understand behavioral biology. So grouse, for the non-grousers in here, they kind of fly in low coming to Lex, and they hit fences a lot. Pete's going to show that some of those fence marking actually is really good for the population. That's not going to be sagebrush ecological integrity, but it highlights that they're very complementary when we're going forward. Thinking about climate change. Our core sagebrush area is climate resilient. And what we're going to see here is if it's blue and it stays dark blue, that means it's stable into the future. If it's light blue on those other rangeland areas and it stays blue, it stays in the future. And what you're seeing on that map is there's awful lots of landscapes that have high amounts of they're going to be stable in the future. We're also showing that 35% of the cores are likely to be lost in the future to climate change. Some of these losses are going to be caused by wildland fire and that interaction. And this is just a prime example of if we can coordinate with these fire programs, and they have quite a bit of resources to deal with these things, these are things where you can potentially mitigate the risk going forward. But it begs a question. If an area is already disturbed now, and it's predicted to get worse in the climatic future, and we already can't defend the core if we're not spending money to defend the core, should we really be working in those areas as we go forward? And these are going to be hard things that we got to get through because there's people that live there and love it and work there. And it's kind of a hard thing, which goes into the last part, which is there's only hope if we manage change. And this is important because change involves people and their hearts, their minds, their emotions. And when you start looking at this, we've got one of our chapters from Katie Wolstein, and it's not just ecological importance. So you can think about greater sage grouse, ungulate migration corridors. You can have whatever you want here. We can map it. But if you don't have the people to deliver the conservation, it doesn't work. If you don't have the political support to transition through administration to administration to administration, it doesn't work. What we're talking about here is 30, 40 years of conservation and where we're going to end up in the future. I think a lot of times people probably think they're working right there. We got social capacity and we're in good ecological conditions. The challenge is they're not thinking about the status and trends of the threats in that landscape and how many resources that they have. And so even though you might think that you're working in the sweet spot, a lot of times we're working out there. And that's a challenge. Expanding that conservation tent to get broad in the thing. So it definitely benefits sage grouse, sagebrush ecological integrity. It's also easier from our ag folks to talk about fighting invasives and conifer and what it does for water and forage production. And so we got to think about expanding that tent to get it done. Something that doesn't sound very fun, conducive administrative conditions. And I'm going to put that in 2 camps. One is just broad scale leadership. How do we go from targeting here to targeting there when people live and work there. That's hard to do. That is flat out change management. Otherwise, maybe not as equally as important, contracting, getting the money from the federal government out to the people that need to deliver it, NEPA, all that other stuff, it matters, is the bottom line. Going back to that first slide when we're looking at the biome wide, we still have wide open places on a scale that folks in the East Coast do not have. If you're looking at some of the western core areas out in Oregon, that's the size of an East Coast state. You start thinking about Wyoming and those areas that no matter analysis what we do, Southwest Wyoming is popping up. They're huge. So with that, I'm going to say it again. Thank you to the co-authors. Monumental effort. And what I was told by the editors at Rangeland Ecology and Management, they've never seen a group actually deliver it all on time. And that just goes to show the committed nature of these folks. We're going to hear about a lot of these themes, but just to reiterate, business as usual is not going to save the sagebrush sea. Spatial targeting is part of the solution. If you don't understand status and trends, you cannot have a conservation plan. We've done it at scale. Theme 4, sagebrush ecological integrity is ecologically relevant. And that last part, there is only hope if we manage change. So with that, thank you.